Hello, this is Mr. Newman again, and I am going to show you how to use the law of cosines. In these two examples, I cover both the possibilities of using this law, and as I mentioned in the last video, there are two situations where you might need this. One is, as you see right here, where we know an angle, but we do not know the opposite side. If you remember, to use the law of sines, we need to know an angle on the opposite side. Here, all we know are the angle and the two adjacent sides. Okay, so I'm going to show you how to do this. Let me put the law of sines up here real fast. The law of cosines. And if you remember and notice, the capital A is exactly opposite of side A, which in this case the problem calls capital R and lowercase r. Okay, so I'm going to fill out all the different parts for this equation. Now, one thing you should know is that it does not matter which side I choose to be B and C. Those two are interchangeable, because if you notice, right here, B and C, we can switch those two because addition is commutative. And it seems that I made a mistake here. Let me fix this. This should be B and C, 2BC times cosine A. There we go. And then BC right here, those two are also commutative, so we can switch those. So it doesn't matter which I choose to be B, which I choose to be C. Here they're called M and P, but I'm just going to fill out the equation. So I don't know A, that's actually what I'm looking for, A squared. But I do know that B, let's have that be the 5. And let's have C be the 4. Okay, so I'm just going to fill this out. We have 5 here for B and 4 here for C. And lastly, cosine of the angle. I know it's 51 degrees, so I'm going to fill out cosine of 51 degrees. And at this point, it's just a matter of plugging that whole right side into the calculator. So make sure you're in degree mode, and we should get that A squared is equal to 15.8, and I'm going to round it up to 8.3, okay? Now, a common mistake is to say, oh, and we're done, that's R equals 15.83, but if you remember, this is A squared over here. Don't forget the squared, it's very important. So we need to take the square root of both sides, and because R is a distance, it cannot be negative. So therefore, we take the square root of that, and we get that A, or rather in this case R, equals 3.978. I'm going to round that up to 3.98. And we need to put the units on that. That's centimeters. And we are done with this problem. So on to the next one. Now, in this situation, we actually have all the sides. Remember, this is a second possible scenario. We have all the sides, and we need to find theta, the angle. Okay, so here again, it doesn't matter which I choose for B and C, but it's very important which I choose to be A. Let me put the equation up real fast. Alright, and it's very important that since we're looking for capital A, or in this case, theta, it's important that we make lowercase a the opposite side. Okay, if you see that over there. So, let's make that, this will be A here. And then it doesn't matter which is B or C, so let me fill that out. So we have 2 squared is equal to 3 squared plus 4 squared minus 2 times 3 times 4 times cosine of A. Or in this case, I'm going to go ahead and fill out and say it's theta, because that's the side opposite A. Now, let me just compute some of these. So 2 squared is 4. 3 squared is 9, and 4 squared is 16, so I'm going to say 9 plus 16, that's 25, minus 2 times 3 times 4, that's 6 times 4 is 24, times cosine of theta. Now, another common mistake is to add these two, right, or subtract these two right here, okay? You cannot do that because this is multiplied. Alright, because that's multiplied together, we have to first subtract the 25 from both sides and then divide both sides by negative 24. So let's do that. We have minus 25 from both sides. So we have negative 21 equals negative 24 times cosine of theta. Now we can divide both sides by negative 24. Negative 24, negative 24. And I'm going to type negative 21 over negative 24. Let's put that into the calculator. And I got that it is equal to, let's put that in the calculator, 0.875, and that is equal to cosine of theta. And the very last step is we need to find the inverse, we need to find theta, so we're going to use inverse cosine. So inverse cosine of 0.875 is equal to our theta. And when you type that in the calculator, I get that theta equals 28.95 degrees. I'm going to go ahead and I'll round that up to 28.96 degrees. Okay, and if that's if your calculator is in degree mode. If it was in radian mode, you get something else, and I would accept that as well. And that is how you do those two types of problems.